House Bill 104. And first up today is an Edward Pheil. Mr. Pheil, forgive me if I've mispronounced that. Pheil?
Pheil.
Hi, sir. How are you? Floor is yours.
Very good. Thank you. Chairman Vitale, Representative Stein, and members of the House Energy and Natural Resources Committee, thank you for inviting me to testify before you today. My name is Ed Pheil. I am co-founder and chief technology officer of Elysium Industries USA. Elysium is an advanced reactor company seeking to develop and commercialize the Elysium molten chloride salt fast reactor, representing a cross-section between nuclear energy and high-level waste management. Our mission is to provide sustainable, inexpensive baseload and process heat energy while consuming nuclear waste and providing options for nuclear services for irradiation testing, diagnostics, medical isotopes, and treatments. My motivation to found Elysium stemmed from my hometown. I was born and raised near 3 Mile Island in Pennsylvania, which inspired me to dedicate my life to nuclear reactors because I saw that no one was harmed after that casualty. Prior to Elysium, I spent over 3 decades working at the Naval Nuclear Laboratory, the Knowles Atomic Power Laboratory in New York, designing U.S. Navy's reactors for submarines, aircraft carriers, and a Jupiter spacecraft for propulsion and power. I began in operations, training Navy students, then shifted to design, to which I've devoted the majority of my career. To this day, I have been involved in reactor design and support for 9 different reactors, including reactors for the Virginia class, the Columbia class, yet to be deployed, and the Ford class carriers. I have done 15 reactor startups, assisting the Navy with those, as well as design studies for many, many types of advanced reactor technologies. My background is such that people always ask me because I could design more than just water reactors. I want to thank the members of the committee for holding this hearing on a pressing topic for Elysium in the United States' position in the global nuclear technology market. I welcome the opportunity to share with you the potential of the advanced nuclear industry and its importance on both our pollution and carbon reduction, as well as nuclear waste reduction strategies. A primary goal is to mitigate the public concerns with nuclear by design. For example, reduce cost, eliminate long-term waste. Our waste has a 100-year life that's radioactive instead of the current waste, which is 10,000 years or more. And consume all the fuel, minimize proliferation risk, ensure safety through passive design. Nuclear power is crucial to the U.S. energy independence, and the 78,000 tons of stored nuclear fuel and depleted uranium, such as that at Portsmouth, Ohio, can help secure the energy independence for Ohio for the coming centuries, indeed millennia. Nuclear energy represents 15% of Ohio's electricity mix and almost 90% of the emissions-free electricity. Recently, it has been widely recognized by the institutions such as the United Nations Intergovernmental Panel on Climate Change as an important source of power for the future energy mix. Isotope production has also bettered our society and the advent of medical imaging and treatments. Cost of nuclear energy has been growing in the United States for a myriad of reasons. However, the main driver is the lack of research and development incentives and funding to improve currently half-century-old technology. To rebuild the nuclear schools in innovation, design, build, and trade skills are needed, like welding and advanced manufacturing. Building these skills is required for the success of advanced nuclear. The negative perception of existing nuclear technology has abated investment and innovation, and is mostly built on the fear of accidents such as Chernobyl and Fukushima. In addition, concerns around the storage of long-lived spent nuclear fuel waste and the threat of arms proliferation have served as excuses to stymie innovation. Elysium elected its molten salt reactor concept to integrate solutions to these problems by design. Fortunately, the United States developed a portfolio of advanced reactor solutions back in the 1960s and 70s. Elysium is one of the many vendors commercializing such designs. Elysium specifically designed to minimize the cost using liquid chloride salt fuel, that's table salt, and it's low pressure and high temperature, is specifically designed to minimize the cost. And then when we also, at the high temperature, allows us to do process heat temperature to displace other systems where fossil fuels may be used. We can close the fuel cycle by using a fast reactor to consume spent nuclear fuel without processing. So no pyroprocessing, no Purex processing. And we use that as our main fuel and consume excess world plutonium to reduce proliferation concerns by using fuel which is never weapons grade in the reactor. Liquid fuel allows for access to extract medical isotopes or placing irradiation or test cells anywhere in or around the core. The design is specifically designed to maximize flexibility for many uses, including load following. My experience working on all different types of reactors allowed Elysium to utilize the most beneficial features of water reactors, gas reactors for high temperature, liquid metal reactors for low pressure and no boiling, and heat pipe reactors, while optimizing out the challenges of each of these designs. So we take the benefits and leave the challenges behind. The reactor uses low-cost molten table salt, and the fuel dissolved in the salt cannot boil and it freezes if it leaks out. The same reactor vessel is used from very small scale, 10 megawatts thermal, for a prototype test reactor, which we're trying to site, to very large scale, 1,200 megawatt electric, 3,000 megawatts thermal for process heat. There is no new reactor to buy if you want to scale up in power. You just add more heat exchangers and pumps. Easily adding heat exchangers and pumps scales the power, and the reactor has up to 6 loops. When the reactor heats up, the power goes down, so it's self-controlling. The reactor load follows by following the temperatures. If it gets hotter or the pumps fail, the salt cannot boil and the fuel drains out of the reactor and shuts the reactor down. Decay heat is passively cooled by air, or to air with no water required, like light water reactors are, because they're colder. Like other U.S. advanced nuclear vendors, we are planning to construct and operate a non-commercial, non-power generation demonstration at 10 megawatts thermal of the molten salt reactor in the United States. We are currently looking at several sites, including the DOE's Portsmouth, Ohio site, which used to enrich uranium. It is now being remediated, and we are among a group of advanced reactor vendors included in developing an early site permit for that site. Elysium is also developing a solution to the accumulating nuclear waste issue. Our most recent accomplishment includes the demonstration of our nuclear waste to fuel conversion process with DOE National Laboratory experts. This allows us to convert waste to fuel in a much simpler and lower cost and safer process than existing technologies without doing any reprocessing. They consider it conversion, not reprocessing, because we just swap out the oxygen with the chlorides. The Elysium reactor can consume any actinide, stored nuclear fuel, depleted uranium, excess plutonium, natural uranium, etc., while producing massive amounts of energy compared to today's reactors. 30 times the energy from current reactor waste as the light water reactor generated, and almost 300 times the energy if you include the depleted uranium that's stored at Portsmouth, Ohio. Since the U.S. stopped building nuclear power plants, the design and build experience is decaying and needs to be rebuilt. The export of manufacturing jobs overseas allowed the trade skills like welding, electrical, pipe fitting, jobs, and skills to decay away. These skills need to be rebuilt, starting in STEM and basic schooling, including nuclear science, more science and engineering in college, especially chemical engineering, chemistry, materials, and nuclear engineering. We need to rebuild the basic manufacturing skill base to be able to develop advanced nuclear. House Bill 104 will be crucial to spur investment and innovation in Ohio's nuclear industry. The advanced nuclear community will definitely welcome the creation of the Ohio Nuclear Development Authority and Consortium. This will provide us with opportunities for public-private cooperation for the development and demonstration of new reactor designs and components. It will also provide opportunities to pursue innovative solutions to the waste problem by closing the fuel cycle cost-effectively. In addition to improving resistance to state or terror-driven arms proliferation, it would also facilitate non-proliferative U.S. nuclear exports, which contribute to global peace and security. Advanced nuclear presents a lot of promise for our future generations. Needs beyond electricity, such as medical isotopes, industrial process heat, decarbonization of the transportation sector, such as synthetic fuels and hydrogen production, and space travel. This could create job opportunities and drive up the state's exports to the rest of the United States and to the world. I hope my testimony will provide you with the same sense of urgency that the industry faces in leveraging the remaining experienced nuclear reactor designers. The Ohio Bill 104 would be a great step forward in creating a sustainable energy industry and reinvigorate the U.S. leadership in the nuclear industry and gain support from the U.S. public. I look forward to your questions, and I'm happy to provide supplemental information to the committee and its members at the members' request. Thank you.
Okay, thank you for your service and thank you for your testimony. Does anybody have any questions from the committee? Representative Stein.
Thank you, Chairman. Thank you for your testimony here this afternoon. Could you share with us what you see or have seen as the biggest hurdle for you to implement this technology, and whether you see 104 as having a real impact on your success to be able to move your reactor design forward?
Yes, I can. Thank you for the question. So the two biggest issues that we have today are the public's interest and support to get the people that would finance the reactors to actually put forward money to invest in the development. So House Bill 104 would essentially form a consortium that would help motivate and convince the public that the nuclear is important. The other issue that we have is the Department of Energy and the Nuclear Regulatory Commission are having a difficulty developing capabilities of regulating advanced nuclear plants and actually regulating in a timely manner. It takes a minimum of 5.5 years to license a nuclear reactor in the United States, but it takes about 3 years to license a gas plant. Yet nuclear plants don't kill anyone, but gas plants occasionally do. So there's not really a justification for the excess time required to do that. So House Bill 104, I believe, is intended to help Ohio lead the United States in a better regulatory posture to try to get through the regulation and build nuclear plants faster, or especially do research and development for advanced reactors.
Any further questions? Representative Wiggum.
Thank you, Mr. Chair. Thank you for your testimony today. The question I have is regarding just making it, I heard you talk about the fuel conversion several times, such as taking spent nuclear fuel, and that is now, and I've heard this before, it could be reused. And you're saying that can be done, and that's something that you'd be looking at doing.
We have done it.
Okay, you have done it. Then my question is, and what is the what is the byproduct then? And is it as dangerous as the spent fuel rods of maybe a nuclear plant?
Right now, the spent fuel rods have been safely stored for many, many decades. They are not really a serious risk. The concern that the public has is for the 10,000-year half-life plutonium that is in that waste. What our reactor does is it takes that waste, all the uranium, the plutonium, and the higher actinides, and converts it from an oxide to a chloride and puts it in our reactor. Once those actinides go in our reactors, they stay there. They don't come out. Right? What comes out of our reactor is only the fission products. Normally, most of the fission products will decay away to natural background levels in 300 years. But our specific reactor design only takes out the short-lived fission products, and we leave the long-lived fission products in the reactor. So what actually comes out of our reactor in the end is the 100-year fission products, and they will decay to background in 100 years, which is about the lifetime of the spent fuel canisters that are the length of time that they're designed for. And if you compare that to coal ash or things like that, coal ash, it never decays away. It's always there as a hazardous material. But the nuclear waste decays away. If it decays away in 100 years, then it's not a hazardous material anymore.
Under your new reactor design, does it does the plutonium remain, which of course is what people get concerned about with weapons of mass destruction?
So in our reactor, the spent nuclear fuel has plutonium in it. The U.S. weapons program has plutonium in it. Japan and the UK and France all have stored plutonium that they were making into light water reactor fuel. We take any of those sources of plutonium, and the plutonium stays in the reactor indefinitely until it fissions. So the plutonium is completely consumed before it's taken out of the reactor. We actually have to replace the reactor before all the plutonium is consumed and put it in at a second reactor. We have to replace the reactor vessel because it gets damaged. But we take the fuel out, we replace the reactor vessel, and put the fuel back in and continue to consume it. So no, the plutonium does not stay around.
Any further questions? Okay, seeing none, thank you.
Thank you.